Hey there! Let's talk about congruence in geometry. Starting off here, we have two triangles, ABC and DEF. And what it means to be congruent means that they are equal to each other and they're the same size. So let's say AB was 4, 5, and 6, and this would also be 4, 5, and 6. And what it means is that the respective side AB is congruent to side DE, and so on and so forth. What this can help us is that if we were to make a shift or a transformation, we can do that. So let's look at this. So we have a transformation here, and let's say this triangle we have 3, 4, 5 for triangle ABC. And if we wanted to transform it, let's say we wanted to shift left 2 and down 3. So we would move each point to be left 2 and down 3. Point A is 0, 0, which would be shift 2, down 3, right here. And let's call that point D. And B would be shift 2, down 3, right there, point E, and shift 2, down 3, point F. And there's our new triangle. That's just one of the many shifts. Some other shifts are reflections, rotations, or translations. And here's some more. So let's look at a few of these transformations. This is our base one right here in black, ABC. Let's look at the green one first. So what it is, it's pretty much a mirror over the y-axis here. And it's mirrored because if you sandwich the axes together, you can fit them perfectly into each other. So let's say, from what we know, if these were congruent, if we put the green one in here, they'd be the same size, of course, but then we would know that this point would be G, that point would be E and F, or in other words, ABC. And the transformation here is, it is a reflection over the y-axis, which is a different way of writing it, and it's also a change. But they're still congruent to each other because they have the same values, they're just shifted. Let's look at this one right here. In the blue, we have it mirrored over the x-axis, and it has the values. If you sandwich them together, it would be A as the same point as the current A, so let's call this D. This would be F, E, because it's basically DEF going this way. Same thing with here, just a mirror. And that's a reflection over the x-axis because you have to reflect the x-axis. Now for our last one, it's a bit trickier because it's also a mirror. So let's take this base right here, the blue one, and we know that if you reflect it, we get a upside down triangle, but then we have to reflect it again and again. So pretty much you can think of that as a 90-degree turn counterclockwise. If we shifted this triangle counterclockwise, this way, we would get this kind of triangle. And that's what we're doing here. And plus, in addition to the transformation, we'd also shift it plus 5. So next, now we would have to look at other types. Now let's understand congruence in triangles off the graphs. There are many different forms of congruence theorems for triangles, but some of the main ones are, and the only ones, are ASA, angle, side, angle, side, angle, side, 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 angle, side, and there are a few that you aren't supposed to use, like ASS or SSA, and that's about it. And, I meant AAS. And these formulas help us prove that one side of a triangle is congruent to another side. So let's say for side AB, it would be 10. Because we know that they are congruent by side, angle, side, from the side, angle, side, since we know they're congruent, we can say that angle side DE is also 10. And it helps us show and learn what sides are the same, and it can really help for triangle proofs or problems. In addition to SAS and triangle congruence theorems, we also have to know some properties of quadrilaterals, like this parallelogram. Some properties we have to know to find out if triangle ABC is congruent to triangle ADC is we have to know that parallelograms, the opposite sides are always congruent. So we can say these two sides are congruent to each other. Another thing we have to know is that the bisector, the diagonal, is always, by the reflexive property, it's congruent to itself. So by that, we already know that we have the SSS. And thanks to that, we know that triangle ABC is congruent to all the sides and angles of triangle. Be careful here. We have to match these two signs with these two signs. So instead of saying triangle ADC, we would say triangle CDA. And that's because we have to match this shape. So we can redraw this here for a better visual. If we were to draw triangle ADC as this, the 3 congruence mark would go with the C and D. So C, D, and A. Alright, if that all makes sense, some other properties and theorems you have to know are the bisector theorem. You have to know the opposite sides are congruent, opposite angles are congruent, these two angles, over the bisector line. And you also have to know that rectangles are parallelograms with congruent diagonals. In a rectangle, the diagonals are congruent, and that's another key factor. Some congruence problems don't really need to know formulas, but you just need to know the common forms of kind of solving congruent problems. So here we would have parallelogram A, B, C, D, or let's call it quadrilateral since we don't know if it's parallel or not. And the other one would be quadrilateral E, F, G, H. We need to find out which side is congruent with which side. So these markings, angle markings, and the side markings will really help us. So we know that angle A is congruent with angle F. So let's write that down. And that's the congruent symbol. And side AD is congruent with side FG. Make sure the markings match up. And BC is congruent with EH. Knowing that, we can reposition these to look the same. So let's say we would reposition this one to be kind of looking pretty similar. The markings would be the same. So we know that angle A is congruent to angle F, so this would be F. AD is congruent to FG, so we know this would be G. And it's starting to look pretty similar now. This angle, this side right here, would be congruent to BC, so let's say EH. And we know that because the F has to be across adjacent to the other one, has to be E on the top, and H on the bottom. Alright, that's it for congruence for geometry. This has been provided to you by SATFreePractice.com.